To borrow just a little bit of the way that you do things as you become engineers from the way that I, as a historian, conduct myself. I'd like you to borrow a little bit from the way that, from other ways of doing things. Engineers are problem solvers, and historians aren't problem solvers, necessarily. But historians, what they do is they study the past, and they try to figure out what people did and why, as best they can. But then, the next step that makes a historian a professional, an expert, is historians try to evaluate what happened. They try to assess it. They try to say, if we're faced with a situation like this again, should we do things the way we did it in the past, or maybe should we try to do it a little bit differently next time? They try to tell the best story they can about the past, so that we can draw meaning from it, so that we can maybe fix things that didn't go perfectly the first time, or maybe if something went really well, that we can learn from something like that. We might be able to handle problems better if we look at the way that people handled problems in the past and try to see how they did. So historians look at sources, often words, but sometimes they talk to people, sometimes pictures. They look at artifacts from the past, and they try to tell stories about what happened so that we can draw meaning from that. And I'm going to do the same thing. I'm going to tell you a story. You actually probably know a lot about this story. It's one of the most famous stories of the 20th century. It's the story of how Americans first put people on the moon. And I won't go into a lot of detail because to talk about this story in detail would take hours, and I just want to talk for a few minutes. And I want to tell the story in a certain way so that maybe you can draw some meaning from it. Maybe you can see something that went wrong, although this story is almost always told as a victory story, and I think it deserves to be told as a victory story. Maybe after hearing the way I tell the story, maybe you can think that you'll do it differently and better when it's your job to solve these big problems that engineers face. The photo behind me here is one of the most famous pictures taken in the 20th century. It's a picture taken by Buzz Aldrin of Neil Armstrong walking on the surface of the moon. This was taken on July the 20th, 1969. Maybe it seems like a long time ago, but your grandparents were alive then and almost certainly watched this on television. Everybody watched on television that day. I wasn't quite alive, but everyone one generation older than me remembers this day very vividly. This picture represents one of the most astounding engineering triumphs of all time. Maybe the most impressive engineering problem ever tackled by humans and successfully solved. The things that these engineers had to do to send 3 people into space, have one remain in a spaceship above the moon, and then 2 land on the surface of the moon is astounding. I couldn't even list all the problems that they solved as they did what they had to do to put these people on the surface of the moon. In less than 11 years, all of you have been alive for 11 years, the United States went from having no satellites in space to people walking on the moon. It is simply astounding. Every little aspect of it worked perfectly. It's amazing. The Saturn V rocket, the rocket that got these people off of the surface of the Earth and into space, is the largest machine still ever built, the most powerful machine ever built. 160 million horsepower. It's amazing. The spaceship, as it came back from the moon, went the fastest that any human, carried the humans faster than any other human has ever traveled, more than 25,000 miles an hour on the way back from the moon back to Earth. The engineers did this about as soon as they possibly could have. They did this so quickly, they didn't even have the time to test it properly. That meant the spaceship there behind Neil, the lunar module, had never landed on the moon at all when it landed that day. They thought it was going to work. They were pretty sure it was going to work. They didn't know. They were right on the edge of their knowledge, but these engineers succeeded in solving this incredibly complex problem in an amazingly short amount of time. It was simply an engineering marvel. It shows what Americans can do, what engineers can do, if you give them a problem and some motivation and some resources. What they can do is astounding. If we put our minds to something, what the sort of things people can do, something we should all feel proud about. It also shows how ingenious and hardworking and dedicated engineers can be. Give them a problem, give them some resources, and then stand back and watch what they do, because they love to solve problems. They love to find the best way to do things, something in the way that engineers think. I admire it personally, and this is maybe the most amazing thing that engineers ever did, although there'd be a long list to list all the amazing things that engineers did. They love to solve puzzles and problems and to find solutions. And so this is one way to tell the story of the Apollo program. On July the 20th, 1969, after about 12 years of really intense activity, engineers managed to solve these various problems and put people on the moon and then bring them safely back, showing the world how ingenious they could be. But there are other ways to tell this story. This is the story about them as a success is an important way to tell the story. I like that story, but there are other ways to tell the story too. Matter of fact, there are more ways than I'll even talk about today. But I've already talked about one, I'll talk about two more. Another way to tell the story is not really maybe such a happy way to tell the story, a little bit of a tragic way, in the sense that just a couple years after this happened, just a couple years after people first walked on the moon, brought moon rocks back, saw the Earth from 240,000 miles away, the American public became bored with the program, and they zero-funded it. It ended before all the Apollo missions even flew. Aldrin and Armstrong, and then 12 other people, 10 other people went to the moon and walked. And then a few years later, people said, "Well, that's nice. Now we'll do something else." And if you look at it that way, perhaps the story's a little sad. All that effort wasn't seen as something that should be continued. The Saturn V rocket that carried them, 15 of those were built. 15 of the world's most powerful machines ever. Only 13 flew. 2 of them they just took apart because the American public decided to do something else with its attention. And there's even a sadder version of the story. Maybe you know this version too. And that's most people understand what happened and they look upon it fondly. But according to a recent poll, 7% of the American population thinks that this picture and all the other pictures from the Apollo program are fake. That Americans did not land on the moon on July 20, 1969, that it was all done on a sound stage. That this was, engineers couldn't solve these problems, and so they just did it on a movie set, and the pictures aren't real. There's all a big hoax. 7% of the American population thinks that. That's about 20 million people. It's a big group of people, and they look at pictures like this and they say, well, I can prove that this is fake. Look at the flag. There's no wind on the moon. The flag is waving. The picture must have been taken on a soundstage because there was a fan blowing on this, and the engineers who made these pictures were too dumb to realize that people would see that. Or also, notice there are no stars in the sky behind Armstrong. People who say this is fake use that as proof. Why aren't there any stars in the sky? This must have been not on a movie set because they made a mistake. Now, I hope none of you believe this hoax. I dearly hope that none of you do. As a matter of fact, I've met some of the astronauts. MSU invites them here. And so the person who took this picture stood in just about this spot a couple years ago and spoke to a group of engineers who were invited. And another one of the astronauts from the later mission, Charlie Duke, came to MSU and gave a talk. Engineers at MSU get to meet these people, so this happened. And there are explanations for why the flag looks like that and why there are no stars in the sky. But the point here is that engineers solve some of the most complicated and amazing problems in human history, and there are millions of people now who think they didn't. And whose fault is that? And you can say, well, it's these people who don't understand science and engineering enough to know that it's impossible to fake something like this. And if they faked it, why would they fake it 6 more times? Fair enough. You could blame the people who choose to believe conspiracy theories instead of facts. But on the other hand, maybe I think you could very reasonably blame the engineers because they didn't do the work of reaching out to the public and bringing them along during the space program. You could say the engineers maybe didn't do their jobs perfectly. They did a perfect job of putting people on the moon and bringing them back. No one died in the Apollo program, at least the rocket ships actually took off. But they didn't fully communicate what they were doing why it was important, and what they were doing to the public. Remember that engineers solve problems, but they solve problems for people. And so making the machines that you're going to make that take plastics out of the ocean, that's an important problem, and I'm certain that at least one group here is going to solve it, and maybe more. But that's not enough. You also need to reach out to the public and bring them along too. Communication skills are crucial for engineers because it's not enough to solve problems. You have to communicate those problems, and that's what the engineers maybe on this program didn't do as well as maybe they could have done. You need to explain clearly when you speak to people and when you write what you are doing, why the problem you are solving is important, why your solution is a good one, and maybe these robots that are going to clean up the oceans are going to be really expensive. I don't know. Maybe they'll be free, maybe they'll get their own energy from the sun, or maybe they'll be really expensive to build. We don't know yet. If they're expensive, you'll have to explain why it's worth it to build these things. You'll have to bring people along in a way that the Apollo engineers maybe didn't. You have to explain how you solved the problem, why you solved it, why it's important, and why we should value it. I'm sure you will succeed in building these robots that clean the oceans, but that's just part. And indeed, you have to be sure that people understand why. And the rubric that the judges use to grade your project are going to reflect this fact. You're going to have to communicate. Part of your score in the rubric is being able to explain why this is an important problem, how you fixed it. So it's not enough just to build a perfect robot. You need to build a perfect robot and then tell everybody else in a way they can understand, even if they're not engineers, why your robot is great, why it's important, and why it's a solution to the problem. It's going to test your communication skills and your knowledge of history, not just your problem-solving skills. In a way, the people here who have built this program want you to be educated, not just trained, not just people who solve problems, but educated, who can reach out and be part of society and not just problem solvers for a little equation you've been handed. So those are my comments. I'm actually going to, if you don't mind, I'm going to watch you as you go about your efforts today. I think this is really interesting. I want to see what you do. Historians love to watch engineers, at least I do. I study engineers in the past. And so I like to see it, and then I hope that when it's your turn to talk to people about this, you'll do as good a job doing that as you do solving the problems, the engineering problems that we're going to tackle. So thank you for your attention.